Alright, so this is SQL Challenges and Concepts video series. I am Saharsh Bhatnagar, founder of Stellar Smart Academy, and in today's video we'll be talking about window functions. First, we'll start by exploring certain drawbacks of the group by clause and the basic aggregate functions. Then we'll see how window functions in SQL come to the rescue by overcoming these drawbacks. We'll discuss the fundamental concept of the over clause, which is used with every window function. We'll also explore the concept of partition by used inside the over clause. And lastly, we'll explore the hands-on of performing the aggregation-based window functions such as sum, min, max, and average using the over clause. So let's get started. Alright, so before we deep dive into window functions and writing syntax and basic queries using window functions, it's pretty important for us to understand why did this concept arise in the first place. And to understand this, we need to go back and understand the concept of group by clause. When we perform the group by clause in order to perform aggregation such as sum, min, or max, what happens is multiple rows are grouped together into a single row, and this causes single individual rows with the aggregated values. The ultimate drawback of this approach is that we lose identity of the individual rows that contributed to these aggregations. In the current example, as you can see, we are trying to find the maximum amount for each category of products sold. But if you see the result, we get only 3 rows instead of the 11 rows. If I want to associate this maximum amount with every row of my input data, I need to perform some really complex and long workarounds by writing very complex queries in group by. So in SQL Server Management Studio, we'll be using a dummy table called class performance to understand the window functions and the problems associated with group by and aggregate functions. In this table, we have 6 columns: student ID, student name, gender, subject name, marks scored, and total marks. To give you a quick overview, this table consists of data for 6 students, that is data for Patrick, Lisa, Carl, Ethan, Isabel, and Jennifer. The split of genders is 3 males and 3 females, and there are 2 subjects whose data is represented here, that is science and maths. Now, if I want to find out the maximum marks scored for each subject, let us draft quickly the query for the same. So for the class performance table, I want to find out the name of the subject first, that is offering the maximum marks. So I will use the max aggregate function here, and I will include the marks scored column over here. Since I am grouping the entire data into 2 subjects, that is science and maths, I need to use the group by clause to tell SQL which column am I using to group the data into. So I'm going to use it on the subject name column. And let me give a quick alias to the max column here. So I'll call this max marks. Now when we run this query, we can see that the maximum score in maths is 90 and the maximum marks scored in science is 95. But we cannot find out which student or what ID of that student is responsible for getting this maximum score. So this is the problem with group by clause. As you can see, irrespective of 12 rows being present in the input data, we are only getting 2 rows with no information about the student ID or student name who have achieved the maximum marks over here. Now, based on the functionality of how group by works, I cannot simply include the student ID here. If I include the student ID over here, and let's say I also include the student name over here, and I run this query, the query will fail. This is because group by says that whenever we are performing a group by and we are performing an aggregate function, all the non-aggregate columns like subject name, student name, and student ID should be a part of the group by clause. But you can see over here only subject name is a part of the group by clause. So if I include the student ID and student name to be a part of the group by clause, let's quickly add it over here. So I have student ID, student name, and subject name. The problem is when we run this query, we do not get the desired result. As you can see over here, the maximum marks value keeps on changing. Why is this happening? This is not what we expected when we ran the previous query. So SQL is basically creating a group of student ID, student name, and subject name. That is 101, Patrick, and maths. So out of all the 12 rows, it will find out how many rows have the value as 101 for ID, Patrick for name, and maths for the subject name. And as you can see, there is only one row which has these three values, that is 101, Patrick, and maths. And therefore, since there is only one row, there is only one group for this corresponding row, and therefore the value in it serves as the max marks. If we had ran this query for minimum, the same value would have been reflected as minimum. If we ran it for average, the same value would have been average. So basically all our data is being split into groups, but the basis of creating the groups is these three columns, and the combination of these three columns, as you can see, is unique for every row. So we do not have any other row which consists of 101, Patrick, and maths, and therefore there is only one group, and the data with it is either maximum, or it can also serve as minimum or average or sum. So this concept of grouping with multiple columns does not give us the desired result. Now, of course, there is a workaround in which I can display the maximum marks corresponding to each row. So for that, I will be writing a simple CTE. So first, let me group by only on the basis of the subject name, as we were doing earlier, and I'll get rid of the student ID and student name columns over here. So now I will say with CTE as, and I'll enclose the select query inside the CTE. So now I'll say select star from the class performance table, comma the CTE, and I'll give the condition that the subject name column from the class performance table should be equal to the subject name column from the CTE. And in the result set, I want all the columns of the class performance table followed by only one column coming from the CTE, that is max marks. So let's run this query quickly. And now you can see this is the desired result. This is what I wanted. If we see over here, for the subject of maths, there are 6 students, and therefore we get 6 rows. For each student, you can see the marks scored by them, and you can see the maximum marks scored for that particular subject. So there are 2 categories here, or 2 groups here. Since we have used group by subject name, in the subject name column, you can see there are only 2 distinct values, that is maths and science. So the data has been grouped into a group containing the data for maths and another group containing the data for science as a subject name. In the maths group, the maximum possible score is 90, and that has been captured over here. Now I can perform a quick analysis. I can easily find out that Lisa is the one who scored the maximum score in the subject of mathematics. Carl scored 30 points less than the maximum score in maths. Similarly, Ethan scored 55, which is less than the maximum marks scored in maths. So this quick comparison helps us to evaluate the performance of each individual student and gives us a better insight. Similarly, in science, since this is another group, it finds out the maximum marks, and as you can see, instead of one student, now we have 2 students, that is Lisa and Carl, who scored the maximum marks over here. So the workaround is obviously possible, but you can see the length and the complexity of this query when we are using the group by. Not just group by, the same problem is also faced when we are using the basic aggregate functions without the group by clause. So if you are performing aggregations such as sum, min, max, etc. over the entire table, the output result set will only contain one row with the aggregated value. For example, if I want to find out the total amount sold across all categories and all products, obviously the output will contain only one row. And the same drawback persists. If I want to associate this total amount with every row for a side-by-side analysis, I cannot do the same directly. I need to follow the same workaround as we just saw in the group by approach. So each row loses its identity of giving the total amount value. So let's perform the same thing on the class performance table. This time we'll perform an aggregate function, but we will not use the group by clause, and we'll see what issue persists in this case. So if I want to find out the average score across all the subjects and all the students in this class performance table, I will write a simple query such as select average of the marks scored column over here. And as you can see, I have not written the group by clause. So I'm telling SQL not to group the data based on a column or set of columns. Or you can also interpret this as saying, take the entire table and consider that as one group. So when I'm doing the same thing, all SQL is doing is it's taking the marks scored across all these 12 rows, adding them to get the sum of the marks scored, and dividing them by the total number of entries, that is 12, to get the average. So let's give this column an alias. So I'll call it average marks, and I'll run this. So you can see the average score across the entire class is close to 74. Now this might be one kind of an insight, but it doesn't really help us in detail, because if I want to find out the performance of each student in comparison to the average, so let's say I want to find out if a student has scored above average or below average, I need to have the data along this average marks row as well. And the same thing, as you can see over here, seems pretty impossible, because this query is performing an aggregation, which is clubbing the rows together to get one row of data. So the same kind of workaround as we saw in the group by clause is what we can do here to achieve the desired result. So I will write a CTE, I'll say with CTE as, and I'll enclose the same select query inside the CTE, and I'll say select class performance. I'll capture all the columns from this table, and I will say CTE dot, and I'll only capture the average marks from this table. So I'll say from class performance comma CTE, and now we run this query. So now you can see this is what we actually wanted. The average score across all the students is 74, and I can easily compare and find out how each student has performed with respect to the average. So let's say for Patrick, he has scored 70, which is below the average of 74. So Patrick has scored below average for the subject of science. Similarly, Lisa has scored way above the average for the subject of maths. Now this insight is far better than the insight we saw previously, which just returned only one row containing one value, which was the average marks. This time I can perform a quick analysis and see how each student has done with respect to the class average, whether he has scored above average or below average. The same drawback persists over here. As you can see, we needed to write a lengthy CT expression in order to achieve the desired result. So this is where the window functions come to the rescue. The word window basically means intervals of data. So window functions take the entire table, and based on the desired column, they create individual intervals or sets of rows. And then they perform the required aggregate function on each individual window. So unlike the drawback that we saw in the group by and aggregate functions, which was reduced rows or grouped rows, the same does not happen in window functions. The window functions, when they are performing the aggregation, they display the aggregated value alongside each individual row that contributed to the aggregation. So we do not lose any number of rows. In our case, if we see, we want to find out the maximum amount for each category. So the window functions will take category column as the column for creating the individual intervals or windows, and then for each of these three categories, which is camera, smartphone, and TV, they will create 3 corresponding windows. And for each of these 3 windows, we will compute the max function individually. So when we see the output, we can see that for each of these 3 categories, the maximum amount per category is displayed right alongside each row which contributed to the aggregation. And if we had 11 rows in the input, all the 11 rows are visible clearly in the output. So no row is lost or clubbed together or grouped together, unlike the concept of group by and basic aggregation, wherein the rows were clubbed together and the individual row identities were lost. The window functions are used alongside the over clause. If we wish to perform the window functions, we need to use the over clause. The over clause consists of 2 main clauses inside it. The first one is the partition by clause, and the second one is the order by clause. Both these clauses are optional in nature, which means we can skip or ignore either of these or both of these while writing the over clause. The partition by clause is used when we want to split the entire data into individual partitions. This is the same idea that we just explored, which is the idea of windowing. So we take the entire data and we split it into individual partitions or windows, and then we perform the aggregate function for each of these partitions. The order by clause tells SQL in what order or what sequence we should perform the aggregate functions for each partition. We'll cover the order by clause in more detail when we explore the video for window functions part 2. Since the partition by clause and order by clause are optional, what does it mean if I ignore both of them? So an empty over clause basically means that we are considering the entire table to be a partition. So skipping or not providing the partitions is the same as telling SQL that the entire table now behaves as one single partition. So whatever aggregation we are performing will be performed for all the rows, assuming the entire table is a partition. So let's see how window functions cut down the effort of writing those long and complex queries. If you remember the first scenario we had talked about, it was the group by clause. So we wanted to find out the maximum marks scored for each subject, and we wanted to display it alongside each row of the class performance table, right? And we had written this query which was pretty long and it involved a CTE. So let's achieve the same result, this time by using a window function. So first I'm going to write a simple select star from statement. So I'll say select star from class performance. Apart from fetching all the columns of this table, I want one additional column so that I can mimic the result of the group by clause. And this is the max marks columns. So I need to perform the max aggregate function. So I will say max, and then I need to provide the name of the column on which I'm performing the aggregation. So I'm going to take the marks scored column as the column on which I'm performing the aggregation. So I'll say marks scored. And since this is a window function, remember we need to use the over keyword followed by the pair of parentheses. Now the question is, do we keep the over clause empty or do we provide a partition by clause over here? So if you look at the result set obtained by the group by clause query that we wrote for the CTE, in this query we were grouping the data based on the subject because the maximum marks is what we need based on the subject. We do not want the maximum marks for all the 12 students for all the subjects. We want the maximum marks based on the subjects, that is maths and science. So we have to create partitions based on the subject name. So all I'll say is partition by followed by the subject name. So now the window functions, what they will do is they will take the entire table and then split the table based on the subject name. So you can see we have one category or one partition as maths and the other partition is science. For each of these partitions, it will perform the maximum aggregation. So it will find out the maximum score for the first partition, which is maths, and will find out the maximum score for the second partition, which is science. Lastly, I'm going to provide an alias here. So I will say max marks I'm providing the same alias so that we can correlate with the result we obtained in the group by clause or the previous query. Let's run this query. And there you go, the exact same result, the same desired result is obtained by running this one-liner query which involves the window function. So you can see there was no CTE involved, there were no complex queries or any nested select statements involved here, and we were able to achieve the same result that we achieved by writing this long and complex query. So we have the maximum marks, and now it becomes easy for us to analyze the performance of each student based on the maximum marks for each subject. So this is one part of the picture. The second problem that we had faced, which was a drawback in using the aggregate functions without the group by, was that we were getting just one row for the entire table. So if you remember, we had to compute the average of the marks scored for all the students, irrespective of the gender or the subject. So let me run this query to show you the output we had received. So you can see we were getting 74 as the average marks or the average score across the entire class. Now the same thing that we did here can be performed using the window function. So you know the drill, we'll first write the simple select star statement. So I want all the columns from this table, and I also want one more column which is going to act as the average marks column. So I need to perform the AVG or the average aggregate function. So I will say AVG, and I need to perform this on the marks scored column. So I will write marks scored. And since this is a window function, remember we have to use the over keyword followed by the parenthesis. The question is, do we keep this empty or do we put the partition by clause inside the over clause? Now since the average is being computed for the entire table, and since we remember from the concept we just explored, if we are leaving the over clause empty, we are telling SQL that the entire table acts as a partition. So the average is being performed over the entire table, and therefore if we leave the over clause empty, we are doing the same thing, that is computing the average on the marks scored column but considering the entire table to act as one partition. So all I need to do is give this an alias which is average marks so that we can see and observe the same results as we obtained using this long query. So let me run this window function query, and you can see we get exactly the same desired results but with less effort of writing a simple syntax and not involving any complex CTE or nested select statements. And not just performing one window function, we can actually perform multiple window functions in the same query. So first I'll show you the effort it needs to perform multiple aggregate functions without using window functions. So if you see the same aggregate function query that we referred to, which was involving the CTE, now let's say I also want to include the maximum marks scored and the minimum marks scored within the same query. So for this purpose, I will have to write another CTE. So I will say CTE2 as followed by the select query which fetches the minimum marks. So I'll use this query as reference, and this time instead of AVG I will say MIN or the minimum marks scored, and let's rename the alias over here. So I'll call this as the minimum marks. Similarly, I need to use one more CTE which will fetch the maximum marks. So we'll follow the same statement, which is select the max of the marks scored, and I'll simply change the alias over here. But this is not all. I need to include these CTEs as part of the final result set. So I will say CTE2 and CTE3, and I also need to include the columns which I need from these CTEs. So I need from CTE2 the minimum marks column, and from CTE3 I need the maximum marks column. So now when I run this query, I get the desired result set. So not just the average marks, I can now also compare the minimum marks and maximum marks with the individual marks scored by a student. So let's say for Patrick, if he has scored 70, It is slightly below the average of the entire class, but it is 20 points above the minimum marks scored in the entire class. And you can see it is 25 short of the maximum marks in the entire class. So this gives us a better insight. But the only issue here is the multiple CTEs and statements that we have written to achieve this result. But with window functions, we do not need to use multiple CTEs. We can simply include the remaining aggregate functions within the same query. So let's try to get the same output this time using the window functions. So I've already covered the average marks here. I'm going to use one more window function. So this is going to be the min window function. So I'll say min, and I'm going to do this on the marks scored columns. Since it's a window function, we have to use the over clause followed by the parenthesis and giving it an alias, which is min marks. Now I also want to perform the max. So I will say max followed by the parenthesis, the name of the column, which is going to be marks scored, followed by the over clause without anything inside it, and giving it another alias, which is the max marks. And with this effort, which is a very minimal effort, I achieve the same results. So you can see we have the same analysis that we obtained using this multiple line multiple CTE query, which has been performed easily without any hassles by the window function query. So what we just saw was the first category of window functions, which was the aggregate window functions. That is, window functions using the commonly used aggregation functions such as sum, min, max, average, and count. What we will see in the next video, which is window functions part 2, is the commonly used rank based window functions such as row number, rank, and dense rank. So that's all for this video. If you wish to know more about the rank based window functions and the order by clause used in the over clause, please switch to the next video, which is window functions part 2.